All right, so angles and arcs. So we all know what an angle is. So specifically on circles, we are going to be concerned about the central angle. Central angle should be kind of what you think it is. The vertex is at the center of the angle, and the angle goes out so that the two sides end up being the radii of the circle. Okay, so these would be diagrams that have central angles down here. If we want to find the sum of the central angles, if we add up all the central angles in a circle, the sum is 360 degrees because there are 360 degrees in a circle. Okay? So now we have to start talking about arcs. We have two major types of arcs. We have a minor arc and a major arc, and then we can also have a semicircle. Okay. So a minor arc, that would be this example right here. This is a minor arc. It's a minor arc because it is less than 180 degrees. It's less than half the circle. So from A to C there would be our minor arc. And the way how we name this is the endpoints. And then we also do a symbol of a little arc over it. That tells us we have arc AC.
But does that describe if it's a minor? Or
Yep, we'll get to how we know that's a minor just by looking at it when we talk about the major. The arc degree for a minor, we have to be greater than 0 but less than 360. Or less than 180, sorry. Greater than 0 but less than 180. So anywhere between 0 and 180, we are a minor arc. X is greater than 0, but X is less than 180. Okay, so then a major arc. A major arc here would be this portion of the circle. Okay, so the major arc is going to take up a majority part of the arc around the circle, and it's named by the two endpoints, but then it also has to have a third letter in between there somewhere. So for this one, we would have D, F, E would be how we would describe that major arc. Okay, so if we only have 2 letters, it's going to be a minor. 3 letters means it'll be a major. Okay. The degrees of a major arc, it's got to be greater than 180, but it has to be less than 360.
for writing this, could you write it like DEF, or do you have to write it with the...
The F has to be in the middle. Same way how when we do angles and things, you should be able to follow it around. So you either have to say DFE or EFD. So you should be able to follow the letters around the circle. And this measurement should be in between 180 and 360 degrees. And then a semicircle. You guys sure already know what a semicircle is. What's a semicircle? Half the circle. So a semicircle here. So there's our semicircle. It's half the circle. So what does the measurement of a semicircle have to be?
Would it be J?
180.
Yeah, the measurement has to be 180, and you would name it by JKL.
Okay, now how would you tell an arc from a semicircle?
We know it's a semicircle if you know that JL is the diameter. So anytime we know that this value here, so if we're told that JL is the diameter, then we know we have a semicircle. Okay? Because we know that's going to be halfway. All right, is that okay? Yes? So we got a couple theorems here. First theorem, some of these are pretty obvious ones. In the same or in congruent circles, two arcs are congruent if and only if their central angles are the same. Okay, so if they have the same central angle as each other, then the arcs would have to be congruent to one another. That should seem like pretty much common sense. Also, if the measure of an arc is formed by two adjacent arcs, is the sum of the two arcs. So if you have two arcs next to each other, you want to combine them together to make one big happy arc, you just add the two measures together. That also should make sense. We do the same thing for angles. And then arc length. We can actually find the measurement of the arc from one point to the other using this formula. A stands for the angle measure. So A is the angle measure. So that central angle. L is your length of the arc. And 2 pi r, that's your circumference. Okay, so if you're given the circumference, you could just put the circumference down there. Otherwise, you'll be given the radius or the diameter, so you'd have to find the circumference. So we are going to find some measurements. So I'm going to give you the central angle, and then we have to find the measurement of the arc that corresponds with that central angle. So in circle F, measure of angle DFA is 50 degrees, and that is already labeled for us. CF is, what does that symbol mean? Perpendicular. So CF is perpendicular to FB, so that means it forms what? 90 degrees. So from CF to FB, we've got that marked as 90. We want to find the following measures. So we want to find the measurement of arc BE. So here's BE. So we need to figure out what the central angle is that's associated with that arc. So, yeah, it's 50. Why is that 50 degrees? They're vertical, so that means that the measure of arc BE also has to be 50 degrees. So the central angle and the arc will always have the same measurement, angle-wise. CBE. So CBE, 50 plus 90, so 140 degrees. Is that okay? And then the measure of arc ACE. ACE. Yep, it'd be 180 plus 50. 180 because AB is a diameter, so it's a semicircle. So that gives us 180, and then we had to go 50 more. So 180 plus 50 is 230 degrees. Is that okay? Make sense? All right. Let's look at the next examples. In circle P, PR is equal to 15. Measure of angle QPR is equal to 120. Find the length of QR. So PR here is 15. QPR is 120 degrees. And we want to find what the actual arc length is from Q to R.
Yep, don't you use that formula?
Yeah, so now we're going to use the formula, which says the angle measure over 360 is equal to arc length over the circumference, which is 2 pi r. Before we just start plugging this formula in blindly, I want to make sure that you guys understand why this formula works. Okay? 2 pi r, the circumference. So think of this like a proportion. Angle measure over 360. When we look at a central angle, is it just a part of our entire circle? Like is PQR just one section of our whole circle? Yeah. So 120 degrees over 360. So we took our one section over our whole circle. So that's this proportion. What is circumference mean of a circle? The whole distance around. So look at this. The whole degrees around are in the denominator, and the whole distance around is in the denominator. Angle, the part of the circle we're looking for, and then arc length would only be that certain part of the circumference that we're looking for. So it's really just a proportion. It's just this formula works every time because it's the general proportion setup. So we just need to fill in what we know. So what do we know? So 120 over 360. Asking for the arc length. What's our radius? 15. How do we know the radius is 15? Yeah, it gave it to us at PR. So if our radius is 15 here, what is 2 pi r? 30 times pi. Good. Is that okay? Oh, we have to solve for, we will. How would we get arc length alone? How would we get the L alone here? Times by what? Yeah, just times by 30 pi. So we just have to take 120 over 360 and then times it by 30 pi. Let's go to the nearest tenth, 31.4. And we weren't given anything here, so I'll just call it units. Is that okay? Okay, so let's look at the next one. In circle B, AC is 9. The measure of angle ABD is 40. Find the length of AD. So A to C is 9. ABD is 40 degrees, and we want to find what the AD is. Yeah, so the same idea. So angle measure over 360 is equal to arc length over 2 pi r, or the circumference. So what's our angle measure? 40 over 360 is equal to the arc length over. Well, now, this says 2r. 2r is also what on your circle? The diameter. Are we just given the diameter here? Yeah, we're given the diameter is 9, so let's just write this as 9 pi. You certainly could divide the 9 by 2 to get the radius first, and then times it by 2 to put it back in the formula. That's fine, but it seems a little redundant. So how do we multiply, or how do we get L alone? Multiply by 9 pi. So take 40 over 360 and multiply by 9 pi. What does it end up getting you? So it's the nearest 10, 3.1 units. Is that okay? Make sense? All right. Then here I want to find the measure of angle AOD and the measure of angle AOE given this diagram. So we have to look at this diagram and figure out some things that we know for sure. So we know for sure in a circle, the whole way around is how many degrees? 360. What else do we know for sure? Half is 180. Okay, so we're going to look for either the whole way around or half.
Can't you equal them all to 180 and solve for it?
Yeah, these three, if we add those three up, what do they have to equal?
Half
180.
Yeah.
So we'd go, okay, so 25x plus 2x plus 3x should have to equal 180. So 30x is 180, so what's your x? 6? Okay, so if x is 6, what should we do with that?
Plug it back in.
Plug it back in. Okay, so if x is 6 here, 3 times 6, what would that be? So that's 18 degrees. 2 times 6, that's 12 degrees. And 25 times 6, 150 degrees. All right, so we want to find AOD. AOD. How are we going to find that?
Wouldn't you just add the 2x, or 12 and 18? Because they come.
Yeah, we would add those because it's vertical. So 12 and 18 is what? 30. So AOD should be 30 degrees.
You don't have to use the formula for that?
When you just subtract
Nope.
that from 180 then, to get it in.
Yep. So then to find AOE, here's AOE. Yep, AOE would be either vertical to DOB, or you could subtract from 180 because it forms a line with AOD. But either way, what do you get for the measure of angle AOE? 150. Does that make sense? Yes? Okay.
How do you do it?
So your assignment for tomorrow is page 533, 14 to 23, and 32 to 43 all.